Welcome everyone to the first meeting of 2024. The new year, hopefully more clear skies in the new year. I'd like to acknowledge that the RASC Halifax Centre, in the spirit of reconciliation, acknowledges that we are in Mi'kma'ki, the unceded ancestral lands of the Mi'kmaq people. Here in Mi'kma'ki, the treaties of peace and friendship recognize the Mi'kmaq and Maliseet title and establish rules for an ongoing relationship between nations. So the RASC and the RASC Halifax Centre believe in and practice inclusivity and diversity. We are opposed to all forms of unlawful and unfair discrimination. So this is the agenda for today. We'll start off with a photo montage, and then just to remind you that Calendars and Explore the Universe guides are for sale. I think Jerry must have them.
Yep, there's one left.
One calendar left.
One calendar
Okay.
left. Judy could advise us whether there are others beyond that, but no.
No.
So there's
Okay.
one left.
It's one collector's item. One left. Then we'll have a special presentation by Pat Kelly. I think that after Pat's presentation, we'll have a short social break for 15 minutes or so. And then I'll talk about outreach. We'll have food for the soul, news from the board, and what's up in the January sky. Before we get into the montage, I'd like to welcome two fellows from the Dalhousie Astronomy Society, Liam and Eamon. Nice to have you here. All right, photo montage. Oh, well, there you go. Good for you then. Certainly in Halifax, the fog came in. Lights are supposed to be clear, and it just fogged up.
Yeah, never made it to Bedford, which is
Yeah.
good.
All right. First one up is Jerry's. Jerry Black took this image of the Heart Nebula. This was at SCO, right, Jerry?
Yeah. Yes.
And next one, please.
Are people getting this presentation on Zoom?
Yes, it's showing up nicely.
Okay, great.
Good. And the Helix Nebula. Always a nice one. And love this one, the Crab Nebula, Messier 1, in Taurus, also from SCO, right? Michael Boschat grabbed these two images of a geminid meteor and part of a fireball trail as going through Orion. And as usual, Michael captured these from his a window in his apartment. I think he said he looked out the hallway window to get those.
I don't know how he does it.
I know, and he just hand holds the camera. He doesn't put them on tripod or anything.
And no one's called the police for this man hanging
with a camera. Exactly.
He did mention there that he got called about a month ago. They came to investigate who was hanging out the window with binoculars.
Next one, please. Barry Burgess grabbed a picture of the aurora. So we have
Does that follow him around? Like, I mean,
you think so, right? I know, it's insane. But that's quite a nice one over the lake. Next one, please. And Geminid over Chester.
with Aurora.
With Aurora, a bit of Aurora background. Yeah. David Chapman, using one of his classic, I think it's his classic Pasco telescope and afocal imaging, these shots of the waxing and waning crescent moon. And we're slowly getting Dave converted into imaging. John Reed loaned him his ZWO C-Star S50 and to play around with. And this is one of the images of the Orion Nebula that Dave took right off the C-Star. So no other. I don't think there was no other processing.
I think he's discovering he can stay inside where it's warm.
That might be. Jason Dane, I thought this was really cool image of a geminid meteor over the lake. I don't know if
Do
that's
we
still
know if
water.
That's the reflection of the meteorite in the water.
I think it is.
Yeah.
I think it is. And this one was picked up by a few sites. It was appeared on Earth Sky as one of the photos of the day. And
Is that the one who got the APOD?
no, that's Gaurav Singh got the APOD. I've got that later. Where else did I see this? I think I saw this in a couple newspapers too. So they're really nice. Next one. I think that's Jason also got a bit of aurora. Picture was one of the nights when it was only a G1 or a G2 storm. I
Giving them a GPS tracker on the various vehicles.
think. Yes. Next one, please. And star trails, also from Jason. Nice reflections in the lake water, and you can see a bit of aurora in the background too.
Those satellites going through.
Probably, or planes. Sunrise and moonrise, courtesy of Jason. Nice wintry scene there. Next one, please. And NGC 1333 in Perseus from Jason. Nice reflection nebula. And the Tulip Nebula, also from Jason. And Big Doucette posted this image of the Flying Dragon Nebula, Sharpless 114. I think you best to use the Hubble palette for this one. Next one, please. And Paul Gray, Jupiter. So Jupiter's still pretty prominent in the night sky, nicely placed for observing and imaging.
The screen isn't doing that justice.
No, it looks
much
much
better here.
better. Yeah, yeah. The screen does pixelate some of these pictures. Now this one, screen's doing this one justice. This is also from Paul, the Clavius crater. One of the best shots of the Clavius crater I've seen. It's really nice. And I took this image of the hydrogen alpha of the sun on the 13th. They were pretty cold, but I went out to image this because there were a lot of filaments visible. Quite neat. Also, the screen's not doing it quite the justice. Next one. And the waning gibbous moon, imaged early one morning. Copernicus crater. Monkey Head Nebula, and that was kind of an incidental, but I took this picture because Vesta, which is one of the brighter asteroids, was passing near the Monkey Head Nebula. Please. And a couple star clusters in Perseus, NGC 1528 and 1545. Stellarium calls them the M&M double cluster. Don't know why. Blair McDonald, nice shot. Core of the Heart Nebula. You said that's the work in progress, Blair?
That's the work in
Yep.
progress.
Yep, so it'll be even better. Excellent, please. Triangle and Galaxy from Blair. Ryan and the Running Man Nebula. Blair. Like this is a nice wide angle, wide field shot of part of Orion, and you can see the Orion Nebula, the Running Man, the Horsehead Nebula, the Flame Nebula. Is that the Flame or Burning Bush?
It's flame.
Flame. It's called Flame. Okay. And the Belt of Orion. So Blair, those were all from Bedford.
No.
Ah.
The mosaic with the last one you
Yeah.
said was from St. Croix.
Oh, okay.
So was the Orion Nebula. And the Cardinals from Bedford.
Next one.
Almost like pollution.
David McMillan sent this one in. He was bemoaning that he hadn't been able to get out to observe, so his December stargazing was putting a puzzle together, the celestial chart. Pretty cool puzzle. Next one, please. Bob Russell, using his ZWOC star, grabbed this image of the Orion Nebula, and this had some post-processing done with it. Next one, please. And Bob Russell took this at SCO, just to show you how nice the dark skies are out there. The Orion front and center. And this is probably the jewel of the montage. This is Gaurav Singh, a Geminid fireball, and Jupiter to one side, and this one was chosen as the astronomy photo of the day.
Would that be one of the moons? Right?
Yep. Again, it's a bit pixelated because of the screen, but it's actually two moons.
It looks like the Hyades and the Pleiades are in that shot.
Yeah, you're right. Right, Judy? There's Pleiades and Hyades. So kind of one of those wonderful lucky shots that you get occasionally. And I think that's it, right?
Yeah.
Perfect. Okay, so next it's
Be after selling apparently 2 more calendars.
oh, okay.
Dave
Update.
Chapman says he also had a spare one. So
Okay.
there are 2 officially
Okay.
out here. 1 here. So, all right, you're right.
Perfect. So we're gonna have a special presentation from Pat Kelly.
Okay, so ready to go then?
Yep.
Yeah, once I figured out how to get rid of this Zoom thing across the top of my screen. Okay. So we'll know more when Europa Clipper, which is NASA's probe, gets to the Jupiter system, and it's not scheduled to launch until October of 2024. So we have about a year or so until it's on its way, and it's going to get there in 2030. So are there any questions? If you were here for my last presentation, this is how it ended.
Yes, actually, I had a question on the last presentation. What type of engine? Like, is it a level 3 plasma, or how are they getting there? Like almost 5 years faster than the last probe that went to Jupiter?
V8.
I think they're using gravity assist, which I'll be talking about today as well.
Okay.
It's sort of a way to get you there on the cheap. It does take a bit longer, but until you develop impulse engine and you're stuck using chemical rockets, that's sort of where you're going to be. So after I did my last talk, I was just casually reading a news item about something and made the sort of mistake that a lot of people do, and that is to forget that there are other groups on Earth doing space other than NASA. In particular, there's the European Space Agency, and you can imagine my surprise when I learned that not only is the European Space Agency planning to send a very special probe to the Jupiter system, it had already left Earth. So they sort of got the jump on NASA, at least in terms of getting started. And I couldn't really think of what on earth I was going to use as the top title for this topic. But given the acronym that they've come up with for this spacecraft, I decided to call the title "Give It Some Juice," which is the name of the spacecraft that is currently on its way to the Jupiter system. And this is an artist's illustration of it, but I'll show you it in more detail in just a bit. If you're wondering how on earth they came up with that name, it's short for Jupiter Icy Moons Explorer. And I can't make this stuff up. I would have thought they could have come up with something a little bit less quirky, or maybe just because it's such a fun name. And apparently for some reason, and I'm not sure why this is either, they actually originally had it all in uppercase and then decided to change it to a capital J, lowercase letters for the rest of it. I really don't understand, but that's what they've decided to do. And JUICE is already on its way. It was launched in April of last year. So it was launched before I even did my talk about the outer planets. And it was launched as usual. They don't use anything fancy. They're not setting up on one of the giant.
Right, we lost your
Starships or-
audio for a second here.
I don't know what that means. If you like, I can search the web for. Hi Siri, we lost your audio for a second here.
All right, are you there?
I'm here.
Okay, thank you.
Okay. So as usual, the European Space Agency launches its spacecraft from their base in French Guiana down near the equator using one of the tried and true Ariane rockets. So this is it on its way. So it was launched in 2023. It's not going to get to Jupiter until 2031. So it's going to take it a little while to get there. In fact, oddly enough, it's going to spend a fair bit of its time bumping around the inner solar system, as we're going to see. And the mission is going to end in March of 2034. So they're expecting the probe to last for 3 years once it gets to the Jupiter system, and they hope it completes all of its mission during that period of time. So it's going to take a rather roundabout way of getting there. So it was launched from Earth at stage 0. So it's launched in April of 2023. And one of the problems with getting into the outer solar system is the Earth is moving around the sun fairly quickly. The Earth is also rotating on its rotation axis fairly quickly. So if you launch from the equator and you launch in the direction the Earth is moving, you've got those two things combined together and you can get a reasonable amount of speed. The problem is you're going around the sun in the same direction as the Earth is, and you want to go in the opposite direction. You want to hit out at a right angle to that. So what they're going to be doing is using a couple of gravity assists from both Venus and the Earth to change the orbit of the spacecraft to then sling it relatively quickly out to the Jupiter system. And a way to sort of think of how this would work is imagine that you're tossing a softball across a road. So you've got a north-south road. You're standing on the east side. You want to toss the ball to the north, but you can only toss it efficiently towards the west, across the road. Well, if you throw it across the road when a truck heading north happens to come by, you can have the truck hit your little ball and send it off in the direction towards north and rob a little bit of energy from the truck. So that's sort of how a gravity assist works. So the first one is coming up August of this year. By the way, the GA here does not mean that the Earth is hosting the General Assembly this year and Venus is hosting it in 2025. The GA here just means gravity assist. So there's going to be one as it passes Earth in August 2024. That's going to send it in towards Venus, where there's going to be another gravity assist in August of 2025. So it's going to take it a year to go around. A year later, September of 2026, it's going to come back past the Earth for another gravity assist. And then finally, in 2029, it's going to get its final gravity assist from Earth. And remarkably, when it gets up to stage number 5, Jupiter insertion orbit over here, 2031. So it only takes it 2 years to get to Jupiter. But you have to spend a couple of years before that bouncing around the solar system, the inner part of the solar system, to do that. So it's going to go into orbit around Jupiter. It's going to then transfer into an orbit that's going to take it fairly close to Europa. So the next phase of the very short time, it's going to study Europa, because Europa is thought to have large amounts of liquid water. It's then going to change to high latitude phase where it's passing over Jupiter at high latitude. And then comes the really fun part of it. It's going to change its orbit and actually go into orbit around Ganymede. So one of the main goals of this mission is to study Ganymede in a lot of detail, because it hasn't really been studied well by the other probes that have actually gone into the Jupiter system. And it's going to finish up March of 2035 in the Ganymede system. So it's not going to drift through space or be crashed into Jupiter like most other probes are. Now, there's a bunch of challenges in actually doing this type of probe. The first one is one that's not obvious at first glance, but it's the huge temperature range. Normally, if you're sending a spacecraft into Mercury or Venus, you know it's going to be hot and you prepare for it being hot, and you don't have to worry too much about it being cold. If you're sending a spacecraft to the outer planets, you have to worry about them being cold and not hot so much. But when you're using Venus to do a gravity assist, you have to design the spacecraft so its components can both handle a large range of temperatures, hot when it's near Venus, and cold when it gets up to Jupiter, where it's actually going to perform its main mission. Another problem that they had to deal with was power generation. And the reason for that, as we'll see, is this spacecraft is considerably larger than any other probe that's ever gone to the outer part of the solar system, has a lot of instrumentation on it, and they require a lot of power. And it has, as a result, 85 square meters of solar panels that had to find a way to be folded into the nose cone of the Ariane 5 rocket when it was actually sent into orbit. And then, like most spacecraft, they unfold once they actually are fully deployed. An even bigger problem is dealing with radiation. So the main components of the spacecraft are actually inside two vaults. Over the course of the mission, they expect the spacecraft, the vital components, to receive about 50 kilorads of radiation versus 2 megarads, which is what it would receive if they didn't shield it with these lead vaults. And just to put that into context, 1 kilorad of radiation will kill a human. So over the times in the Jupiter system, there's a lot of radiation to deal with, mostly because you're traveling through the equivalent of the Van Allen belts on Earth, where there's electrically charged particles and very hot plasma, plus your standard things about being out in space where you've got ultraviolet and gamma rays and cosmic rays and all sorts of other stuff. And of course, you have to have a fairly smart system because the round trip transmission time, once it gets to Jupiter, is over 90 minutes. So it has to be capable of actually performing fairly complex maneuvers. And in fact, this spacecraft is going to have 35 different times when its orbit is going to be changed, either by a gravity assist from one of Jupiter's moons or by using the built-in gas thrusters that are on the spacecraft already. So this has to be smart enough to be able to deal with all of this on its own and not rely so much on humans being able to deal with things on very short notice. So here's the spacecraft. Just to give you a bit of a feel for just how big this thing is, this is a person standing here inside the main deflector dish. Oh, my mistake, that's not a navigational deflector, that's in fact just a radio telescope. So this is what's going to beam information back towards Earth. And you can see that when it's launched, it's going to weigh 6 tons. And I've never really seen this before. It has a dry weight of 2.5 tons. The dry weight means that's the weight of the spacecraft before they add all the propellant to it, which is then used for doing all the maneuvering, orbital changes, and everything else. And to give you a bit of an idea of how that compares, Juno, which is NASA's probe, which is currently in orbit around Jupiter, studying mostly Jupiter, is only 1.5 tons. So this thing has a ton more of instrumentation and everything else on it. And it's got, as a result of the complex maneuvers it's going to be making, it needs an awful lot of propellant. So just over 3.5 tons of propellant. To power all this, the solar panels are expected to produce about just under 800 watts at the end of life. So they'll start off more efficiently, but they degrade because of the radiation problems and everything else. And again, to give you a bit of a feel, that's twice the power output of the solar panels on the Juno spacecraft. It's got just over 1 terabit of memory. And again, this will degrade, so it's made with dually redundant systems, and that's what's going to have at the end of life. The communications rate through this big antenna is going to be about 1.4 gigabytes per day. And you can imagine if your internet connection at home was limited to 1.4 gigabits of data per day, you'd be screaming bloody murder. But that's what you have to deal with when you're dealing with sending data from that far out in the solar system. And of course, there's a whole bunch of instruments around here that I'll just mention in a little bit. But as you can see, it's a very, very large object. And again, it's about twice the size of the actual Juno spacecraft as well. So it's a very ambitious mission. And because we aren't in Europe, we don't tend to think of what the European Space Agency is up to. So I was quite surprised to find that this thing was not only planned, but was already actually on its way. So the instrumentation that's on board, there's a lot of it, which is why it needs so much power. Most of it has acronyms that are fairly straightforward. So it turns out the Janus camera system is named after the company that makes it, called Janus. They do camera systems for all sorts of things. This is the one that's going to be used for just doing regular pretty pictures, just in the visual. Then we have this one, which is the visible and infrared imaging spectrometer. So this is going to look at the planets and the moons, both in visible light and infrared light. But in particular, it's going to actually spray them out and look at the spectrometry of them. And there's also one for the ultraviolet. So the UVS simply stands for ultraviolet spectrograph. We have a radar sounder. So this is similar to the device that was used on the Magellan probe, which went into orbit around Mercury and was able to map the surface, or not Mercury, Venus, was able to map the surface in 3 dimensions by bouncing radar signals off the surface of the planet, timing how long it took to get from the spacecraft to the surface and back again, and then knowing exactly where the spacecraft was relative to the actual center of the planet, was able to figure out exactly the distance from the spacecraft to that point on Venus, and you can work it out in 3 dimensions. Now, in the case of the systems, the moons in the Jupiter system, they aren't covered with clouds, but this is still a really good way for actually getting maps of the actual surface in 3 dimensions. And there's also a laser one, which is going to be used for producing even higher resolution maps of certain parts of the system. There's one for studying sub-millimeter radio. As usual, there's magnetometers for studying the magnetic field effects of both Jupiter and Ganymede, as we'll see. There's one for studying the particle densities on the plasma, the makeup of the thin gas that permeates the Jupiter system. Another one for studying the Jupiter system in both radio and looking at the plasma that's there. This is kind of a neat one. It's the 3GM stands for Gravity, Geophysics, Galilean Moons. And this is a highly precise radio oscillator that's going to actually study how the gravitational field of the whole system varies as the spacecraft moves through it. In particular, when it's in orbit around Ganymede, this is going to help map out the density or the changing density inside the actual moon itself. And then there's also a radio interferometry and Doppler experiment called, which the acronym comes up to PRIDE, so Planetary Radio Interferometry and Doppler experiment, and of course a radiation monitor to keep track of how much radiation the spacecraft is undergoing. So that's what all those weird little things are that was being pointed to in the previous diagram. And as you can see, that's a lot of instrumentation, and that's part of the reason why you have to have almost 1,000 watts of power to power them. And in fact, I was thinking the other day that if 1,000 watts is roughly about a hairdryer on the medium setting, and even here at the surface of the Earth, if you wanted to power one of those continuously just using solar panels, you'd probably need a fair bit in the way of solar panels to do it. So it's understandable that if the spacecraft has a 900 watt power demand to keep everything running, and it's way out of Jupiter where the sunlight is so much fainter, you need a lot of solar panels to do it. So why are they going out there? Well, there's actually 5 main goals of this mission. The first one is they want to find out what the 3 large water worlds out there are really like. And the main reason for that is because of the water content. We now know that all of those 3 of those moons out there have oceans of liquid water beneath the surface. And in the case of Earth, if you take the total amount of liquid water on the Earth's surface and count that as 1 unit, Europa is thought to have twice that amount. Callisto is thought to have 5 times that amount. And Ganymede is thought to have up to 27 times that amount. So there's a lot of water up there. And of course, if you're looking for life, that's one of the key things you want to actually study. Look for places where there's liquid water, because we think that liquid water is key to having life. So that's one of the main things they're going to look at. They're going to take detailed studies of all of the moons, but in particular, the 3 ones that have lots of water on them. The second reason why they're going there is to see if there could be life in the Jupiter system. Now, in this case, it's not so much looking for life per se. What they're looking for are the chemicals and the elements that you need to have life. So things such as carbon and nitrogen and oxygen, or at least life as we know it. Because there's no sense looking for life as we don't know it, because we don't know what we should be looking for. And the main reason that they're so interested in Ganymede and the water worlds is because if they do have a liquid ocean that's underneath this ice layer, we know that they also have volcanic activity going on inside them, which is keeping the water heated because of because of gravitational interactions between Jupiter and the moons and between the moons themselves. So there's tidal effects that continuously sort of slowly deform the shapes of these moons, and that friction from the deformation heats them up. And if you have volcanic activity on the ocean floors, you probably have a chance for life to develop down there, because we know that on Earth we have black smokers, as they call them, volcanic vents on the ocean floors along tectonic areas. And we know that there's life down there that is unique to those parts of the Earth. They don't rely on sunlight. They don't rely on anything on the surface for food. They get all their energy from either dissolved minerals coming up out of the actual water, or by doing the other sneaky way, which is eating the things that rely on all the minerals coming up out of the hot water for food. So from that point of view, they're not looking for life in the same way that, for example, that the Viking landers on Mars were looking for life on Mars by actually having some experiments to actually look for life. They're looking more for whether or not the conditions that might be suitable for life are there, and if they are, which moons are they on, for further study. Another reason this is going up there is they want to find out how Jupiter and its moons interact with each other. And the Jupiter system is incredibly complicated, not only because Jupiter has a very strong magnetic field, but because there's also clouds of sodium that are coming off of Io. So there's ionized gas all through here. There's actually an electrical flow of electrical current between Io and Jupiter that runs along the magnetic field lines. And as we'll see, the thing about Ganymede is it also has a magnetic field. So as these things move around and interact with each other, from looking at the system from out where Ganymede is, it will have a unique view of the entire system up close, but not too close. So they can sort of get an overall view of what's actually going on with it. They also want to look at how a typical gas giant is formed and how it works. We only have one gas giant, one really big gas giant in our system, which is the Jupiter system. And although the Juno mission from NASA is also studying the Jupiter system, JUICE is going to complement that, the information coming back from Juno, and hopefully that will allow astronomers to actually get a better understanding of exactly how these large moons and how the systems of them actually form and how they sort of evolve with time, especially systems that have lots of large moons orbiting around and interacting with them. And the last reason why they're going there, and possibly the principal reason why the mission is ending where it is to try and find out why Ganymede is such a unique moon compared to the other ones. Now, granted, each of the large moons of Jupiter is sort of unique in its own way, but Ganymede hasn't really been studied in depth. There's been some spacecraft that have actually gone fairly close to it, but this one is far enough away from the radiation belt so you can actually go into orbit around it for an extended period of time and study it. And as you can see just from this view, it has some very, very weird terrain. It's got these weird impact craters that have clearly turned up some nice, fresh ice. One of the biggest mysteries about Ganymede is it has not only a magnetic field, it actually has aurora. Now, the aurora, which is depicted here by this blue, can't be seen in visual light. It's seen in the ultraviolets. This was detected, or this data is from an ultraviolet view of the planet, of the moon. But one of the biggest mysteries is there's really only 3 objects in the solar system that are sort of solid objects that actually have really strong magnetic fields. There's the Earth, there's Mercury, and there's Ganymede. And one of the big mysteries is how is that even possible? In the case of Venus, Venus and Earth are almost identical. And the main reason why it's thought that Venus does not have a magnetic field is because it rotates very slowly. So in the case of the Earth rotates every 24 hours. It's got a liquid core of an electrical conductor, which is iron and nickel. And because it rotates very rapidly, it has a magnetic field. Venus should be something similar on the inside, but because it rotates incredibly slowly, it does not have a magnetic field. In the case of Mercury, it's almost all iron core, and its magnetic field is thought to have been sort of left over from the core as it cooled off. And then the question is, well, if that's the case, how can a moon that's made up mostly of icy material end up with a magnetic field? that's comparable in strength to the other one. So that's one of the really big mysteries. And of course, its magnetic field interacts with the magnetic field of Jupiter in a complicated manner as well. It also has these really weird features that are known as grooved terrain. And you can see it, it looks almost like ice that's flowing, sort of. They think it's caused by tectonics, but the process that does this is really a total mystery. And it's also somewhat puzzling as to why you have such sharp boundaries between the area with the grooved terrain and area that has somewhat more in the way of cratering and is sort of less obvious with the grooving, and why those areas also change from very reflective lighter surfaces to a darker material. So it's off to Ganymede for the main part of the mission. It's going to be the first Earth probe to orbit another planet's moon. So we've sent spacecraft that have either flown past other moons or gone into orbit around the planets themselves, but it's going to actually be kind of neat to see exactly what ends up happening when you actually put a really sophisticated spacecraft in orbit around an actual moon, how much data you can actually get from it. This is a list of all of the stuff that you're looking at. I found it was such a long list, I decided to add, and especially its subsurface ocean, because it looks at first glance like a list of everything that the Tasmanian devil would want to study if it went there. And Bugs Bunny comes up and says, what, no subsurface ocean? So yeah, especially the subsurface oceans. So a lot of the stuff that's going to be studied are how it rotates, the gravitational field around it, a detailed view of its shape, working out its interior structure, working out its magnetic field. It does have an atmosphere, very, very thin atmosphere, but there is an atmosphere nonetheless. So they're hoping to try and find out exactly what it's composed of and get a lot more information on the density, what it's composed of in the mineralogy, what minerals are found in the surface of these objects, and that's where the spectroscopy comes in handy. The crust and surface features, emissions into space, that's especially true of Io, which has the sulfur, which is continuously blowing off into the entire system. And of course, the subsurface ocean, how big is it? How far down is it from the surface? And all of these things can actually be discovered by using that vast array of instrumentation that the spacecraft has on board. The end of mission is March of 2035. That's when they expect the spacecraft will run out of maneuvering fuel. So one of the big problems with spacecraft, if you want to move around a system, you have to have a way of adjusting their orbits. And even if you're using gravitational assist, you still have to use propellant to change the trajectory of your spacecraft to get it lined up correctly for the gravitational assist. And because the spacecraft is going to have such a wide range of maneuvering, once it gets to the Jupiter system, they expect that once it goes into orbit around Ganymede, it will run out of propellant to keep its orbit around March of 2035, and beyond that, they aren't really sure how much longer the spacecraft will be usable. What they have done is something that, as far as I know, is relatively unique. Usually what tends to happen with most space probes that NASA has sent, for example, to the outer planets and put them into orbit around either Jupiter or Saturn, is once it becomes obvious that they've reached the end of their usable life because they're low on propellant, they generally deliberately crash them into the planet itself and have them burn up in the atmosphere. Now, these spacecraft are sterilized generally in advance, just on the odd chance, for example, that you send a spacecraft, something goes horribly wrong, it crashes on the surface, for example, of Europa, and then you have E. coli or some other weird Earth bacteria that might survive and contaminate the surface of the planet or the moon that you've crashed on. In a sense, they've done the same thing with JUICE. It has been sort of made as clean as you can get something, but there may still be some spores or whatever still there. So they've decided that what they're going to do is, to play it safe, they're actually going to crash land it onto the surface of Ganymede. And the reason that this is considered to be safe is because the icy crust on Ganymede is considered to be quite a bit thicker than it is on Europa, for example. And therefore, there's almost no chance whatsoever of any microbe from this crashed spacecraft actually being able to make its way down into the liquid ocean that's underneath. And once it's on the surface for a while, the radiation and everything else will probably make whatever's there quite dead. Unless, of course, there's some tardigrades there. They seem to be pretty much indestructible when it comes to radiation and things like that. So that's the follow-up to the last one. I'm hoping that after this one, I don't read next month that the Japanese or some other country has already said yet another spacecraft on its way to Jupiter, and I somehow missed that one. But I thought it would be just interesting just to sort of get people caught up to date and realize that the two spacecraft, both JUICE and Europa Clipper, are going to sort of be working together, with the NASA one focusing mostly on Europa, and obviously the JUICE spacecraft focusing mostly on Ganymede. But they'll arrive there almost a year apart. So even though the NASA probe is being launched this year, it will actually get there slightly ahead of JUICE because of the launch windows and using gravitational assists means that it's going to go there in a very slightly faster orbit or trajectory as it gets out there. So if anybody has any questions, I'd be more than happy to try and answer them. Oh, I should point out, if you want to know where the spacecraft actually is, the European Space Agency website actually has a place on it where you can actually click on a little link, and it will show you exactly where the space probe is at that exact moment. So you can sort of follow it. Right now, it's on the far side of the orbit. It was launched in April, so it's almost opposite us as it's going to be coming around this coming year for its first close encounter with the Earth to do the first of the gravity assists to send it off towards Venus.
Will the NASA probe be in orbit around Europa when JUICE arrives?
I think,
Yeah.
I think Europa Clipper is supposed to be making really close passes of Europa. I don't think it's going to go into orbit around Europa, and that's mainly because Io and Europa in particular are in the area where the radiation levels are really high. So you could put a spacecraft into orbit around Europa, but it probably wouldn't last that long, especially because I imagine if you've got a bunch of lead vaults on the JUICE spacecraft, that's probably where some of that extra ton of mass is coming from. And I suspect that's not the case with Europa Clipper. What it's likely, more likely to do is to have a fairly highly elliptical orbit around Jupiter that will make very close passes by Europa and then get the hell out and then come around, go through, and then get the hell out again. But the NASA one is focusing almost entirely on Europa, whereas the JUICE is looking at all three of those water-based moons, but in particular Ganymede. And it's a complex maneuvering to get into an orbit around Ganymede, which is one of the reasons why it needs so much propellant. And of course, if you think about it, the faster you get out there, the more fuel it's going to take you to slow down to go into orbit around Jupiter. So ideally, what you do is if you sort of think of the orbits of Earth and Jupiter as two circles, the most fuel efficient way to get there is along an orbit where if you draw an ellipse that just touches the Earth's orbit on one side and just touches Jupiter's orbit on the other side. But it tends to take a long time to do it. It's like anything else. If you want to get there faster, it's going to require more energy. So some of that extra propellant is to slow the spacecraft down once it gets to Jupiter, so it won't just fly past it and will actually go into orbit.
Pat, I've read about a proposed mission to drill through the crust of one of these icy moons like Europa and put a submersible in there. Are these missions preludes to that?
I think that would be part of it. And one of the big problems, of course, is how do you drill down through something that could be several kilometers thick, especially if you want to do it without contaminating it. I know that they have been looking at sort of doing some practice work on that in Antarctica, which is both a very cold area, but I can't remember if it's the Soviets or the Russians I can't remember at what point when the Soviet Union broke up, but they were actually doing some rather interesting studies down there by mapping out the actual rock underneath the actual ice on Antarctica, and they were doing that by running deep probing radar, I think it was, in strips across Antarctica to map the landform underneath, and they came across a huge, large, perfectly flat area, which they then realized was actually a lake. I think it's called Lake Vostok, and it's under at least a kilometer of ice on Earth. So if you want to actually try and come up with a way of actually getting through this entirely remotely, that's the perfect place to actually to practice, so to speak. And they've got the same issue there. They want, if they do find a way to get down to it, they want to be able to get a sample without contaminating it with the stuff that you need to drill down to it. But I think trying to do that remotely, I don't know how much. I mean, if it takes 2 or 3 tons worth of equipment to be able to do that, you're going to need a spacecraft that's going to be capable of delivering 2 to 3 tons gently to the surface. You can't just sort of let it crash and hope it's going to rebuild itself or anything like that. But that's the problem, and I think Europa is still favored because I think its ocean is considerably thinner than the ocean on Ganymede, or the ice covering is thicker than it is on Ganymede and Callisto. But Ganymede's got a lot more water, so that's the other thing. So and of course Ganymede is also not in the radiation area. So I don't know if you actually had to pick just the one to go to with the technological challenges. There's sort of there's pros and cons to both, to go into either mode.
Thanks, Pat. Any other questions in the room? No. Any out in Zoomland?
I'll stop sharing.
Okay, so thanks a lot, Pat. That was really interesting. Now we'll take a short break, 15 minutes, so till 10 after 2. People can circulate, chat, have a bio break, get a snack if you're at home, and then we'll come back with Paul Heath's.
I was just going to make some tea.
Can we ask Pat if he's starting up this planetarium?
Pat, we had a question here off the juice topic, but what can you update us on whether there's going to be the planetarium shows are going to start again?
Actually, the person to ask is Stephen Payne, since I think he looks after. He's actually I noticed that he's actually online with Zoom. I haven't done one myself in quite some time, but I think if anybody would know, he might.
I'll address that directly. There'll be no planetarium shows until at least the fall. The dome building is to have a sprinkler system installed, and actually the planetarium dome has to be taken down for that. And there'll be no shows throughout spring and summer. My administrators advised me there's to be no outreach by myself or the department during this sprinkler installation period.
Okay, thanks, Stephen.
I understand that there are free shows at Synchron.
Yes.
Very big.
Yeah. Very realistic.
Yes.
Right. Okay, so we'll have our break now. Okay, we'll pick up again. So before we have Paul Heath's Food for the Soul, just want to mention there are a couple outreach opportunities coming up. I've been contacted by the Young Naturalist Club in Parsborough, who want to put together a stargazing session as part of their winter carnival. So the date isn't firm yet, but somewhere in the area of February 15th to 19th. So keep that in mind. I'm going up, but I'd love to have company.
Also, we've been doing near the end of January.
Yeah.
An outreach for the Halifax.
Yeah. Through at York Redoubt. Yeah. Yeah. I haven't heard from them yet.
I can contact and see if they're going to do it this year.
Okay.
Yeah. It's a great time. First one, David.
Oh, out at Parsboro, Young Naturalist Club for Parsboro.
Yeah.
So I said I'd go up there, weather and roads permitting.
No, their Parsboro group is getting really active. So
Yeah.
it's,
Yeah, I gave them a talk last year via Zoom.
Yes, well, I've done the Halifax Center for about 8 years. We did almost every year. We did a York Redoubt. We did an observing night for the young naturalists. Now, I've been sort of part of the outreach for a couple of years now, so.
I think the observatory here, I think I might have taken that route for late January.
Okay, all right,
Okay.
so, I mean,
Perfect.
I did mention that there was that option, but we'd always gone to York Redoubt because we always had 5 or 6 people to go, but that is probably where they decided.
Yeah.
I haven't heard from them, so that's probably where.
Yeah, the kids were getting cold last year. So.
Yeah.
So,
January's a little chilly out here.
Yeah. There's a wind too. And the other possible opportunity is in Wolfville, February 10th. There might be a chance there for some outreach. I have to get in touch with the person. But it's a fundraising event for the Valley Regional Hospital. They were wondering if they could have some stargazing as part of it.
There is one other one that I just connected to yesterday. A gentleman from the Armed Forces, who's a member of the Armed Forces Space Program. They're looking at doing some astronomy events for the 100th anniversary of the Canadian Air Force.
Huh.
So I just started connection with them to see what they're looking to have and that. So I'll be bringing that information to everybody as it comes up. But they are looking to definitely have some sort of astronomy connection during the 100th anniversary celebrations of the Canadian Air Force, especially the space.
Yeah.
The space group are looking for that. So.
Well, that'll be fun. Okay, Paul. Who's the soul?
Now, some of you may have seen this. Am I on? Yeah. Okay. I posted this as originally as an observing report, but I figured I got so tied up with my book, my new book, that I never got a poem written. So I said I'm going to reprise this one today. Geminid. Upon the stroke of 2 a.m., the wind sharp and brisk to face did sweep the western sky of cloud. So stars did sharpen on the eye. At 2:02, a blazing line was cut, a fiery sword did slice the darkened tapestry about. So quick the blazing sword had struck, the twins their feet no time to lift, and Jove no time his head to duck. So swift, so bright the fiery sword, the startled stars did blink, and mighty Jove his beaming form thrice dimmed by the blazing slice that cut the darkened tapestry above. Upon the eye, the memory of a fiery slice endures. As stars unblinked their eyes and Jove his gleaming glory regained, only the wind-darkened tapestry remained. That was if you notice Jason Dane's image, I saw a really not as bright as that, but this is for a bright meteorite I saw at 2:02 in the morning as I was heading to work. Okay. Just on a personal, the second book is out. It's on Amazon again.
There we go.
It's oh yeah, short prose. It's Love and Passing. It's available on Amazon Books. Enjoy.
All right. Next, we have news from the board with Tony.
Hey, David. Just curious, any new members here today? I think there's one or two, or possibly new members. Oh, hi.
I was absent for long COVID.
Okay, well, it's wonderful to have you. So welcome, welcome. we're very fortunate to have, at least this is my first time as president, so very fortunate to have a bunch of folks who returned to the executive this year. So I'm very thankful for that. Try to keep me on the straight and narrow, and also to David and Jamie, they're new members for the board this year, so real happy to have you on board. Very quickly, just take a minute just to kind of give you a quick update of what we've been up to. We've really established some goals for the year. Okay, yeah, we've established some goals, 5 what do we want to achieve for this year. The first one was, just throw it up there is develop a solid understanding of the wants and needs of the membership. We're really trying to make sure that we keep the group as relevant as we can. So in association with that, you're going to see a note very shortly about a electronic survey we're going to run. And so we're very keen to get your input, so it can help us quite a bit. And I'd ask everybody to give it some thought in terms of your own personal goals for astronomy, as well as what you expect of the RASC in Halifax. Very keen to hear what you guys might want to want or expect from us, because that's very much what we'd like to do with the program. We're going to reinstate the monthly members' night at St. Croix. That's COVID kind of tanked that for us for a little while, so we're really thrilled to get that going. There'll be some advertisement about that, but I think the first night is the 12th of January. So we're hoping, and with the 13th as the weather night. So watch the announce list or the Rascals email list for updates on that. Third one was to promote RASC observing programs and the astro imaging contest. That's a thing that we think we can do some work with. New member recruitment, we're always keen to get some new members again, so we're going to try to do a little bit of that this year, as well as some initiation. So when members join, that they don't just join in the vacuum, we have some way to indoctrinate, mentor, or I'm not quite sure what the right word would be. We'll initiate. And as well, finally, just to implement a maintenance plan for maintenance and development plan for St. Croix. St. Croix is really a jewel in terms of the Halifax Centre. We're very fortunate to have it. It's a great resource. So we want to make sure that we ensure its longevity, as well as perhaps find some Cloud9 ideas and things to develop. So watch your email for the survey. Please give us some thought and tell us whatever's on your mind. And we look forward to seeing you at St. Croix, perhaps on the members' night. So thank you.
So just as an add-on to what Tony was saying, the members' night would be a great chance to for people that want to do the Explore the Universe program to explore the universe. Yeah, you could a year's worth of observers nights, you could probably complete the program. All right, so what's up in the January sky? Next one, please. So days are starting to get longer. So at the start of the month, the sunset was at 4:44, and by the end of the month, it'll be at 5:20. And similarly, sunrise is getting a little bit earlier. So please. This is what the sun looks like today. Most of the current sunspots that are Earth side of the sun are fairly stable, but 3536 is one to watch. It's has the potential to generate some M-class flares, and it's lined up with the Earth. So if it does generate one of those in the next day or two, we might get some aurora. And this is the far side of the sun, an image taken by the Perseverance rover on Mars. And you can see 5 sunspot groups on the backside of the sun, and to be visible by from Mars, they're actually quite large. So we might be seeing some impressive sunspots coming around.
Is that a 90 pixel resolution or something like that?
Yeah. So, yep.
Is that any of the five?
No, that was a shot from yesterday, so they still wouldn't have. It'd be about a week before most of those rotate into view.
Well, I'm just thinking geometry wise.
Right.
Is that, are we actually looking at two complete sides and not half?
Yeah, I'm not sure about that.
They didn't explain that at all.
No, Earth sky was a little vague on that. Yeah. So the moon this month. So we had the last quarter of the winter or the chief moon, and we already had the quaternid meteor shower peak, which was cloudy in Halifax. I don't know elsewhere in the province. Any better, Paul, in the valley? No. So we're probably out of luck for the quaternids, which was unfortunate because it would have been a probably a decent show, even with the moon in the sky. Quaternids tend to produce a lot of fireballs.
I think I caught one. We were out at school, Bob and I. And
Oh,
I
okay.
caught a couple on my time lapse.
Yep.
I don't think I've shared that yet.
Oh, okay, cool.
But they're not spectacular.
So the new moon's January 11th, Tom Cod's spawning moon in Mi'kmaq. And then on the 14th, the moon will be near Saturn. On the 15th, it'll be near Neptune. 18th near Jupiter. 19th near Uranus. 20th near the Pleiades. And then on the 25th, we'll have the full moon. Next one, please. So for observing and potentially imaging for wide field on the 8th, which is in 2 days. Nice shot there. The moon and Messier 4 and Antares. Those would all be in your field of view of 7 by 50 binoculars.
If it weren't cloudy.
If it weren't cloudy. Yeah, we're getting snow, aren't we?
Yeah.
The 15th, if you want to see Neptune in your binoculars, it's a good opportunity because it'll be just to one side of the moon in 7 by 50 binoculars. So it should be fairly easy to pick out. And at a civilized hour, 7:30 in the evening. Next one, please. And while we're talking about the outer ice giants, on the 19th, Uranus will be in that field of view of 7 by 50 binoculars again at a reasonable time, 7 o'clock in the evening in the south. And on the 20th, the moon in the Pleiades. Always a striking view. Again, 7 p.m. You don't have to get up out of bed and go in the cold. Next one, please. Around the time of the first quarter is a good time to knock off some of the lunar features for explore the universe. And the first quarter is around the 18th. So 2 days before and 2 days after first quarter are good times to catch most of what you see in that circled area with lots of nice contrast along the terminator. Planets. So Mercury is pretty low in the southeast, but it is visible before sunrise if you have a good horizon. And on the 12th, it'll reach its maximum western elongation. Venus is very prominent in the morning twilight, magnitude -4, so nice bright object. Mars will be a morning sky object throughout 2024. It's low in the southeast at the start of the month, and see this later. It's a nice, very tight conjunction with Mercury of Mars on the 27th. Jupiter is prominent in the east at the start of the evening twilight. I've already, it'll be near the first quarter moon on the 18th, and there's a double shadow transit at 10:20 p.m. Oh, there was tonight. Okay, so tonight, maybe. point your scopes at Jupiter. Saturn visible in the southwest, but it sets before midnight, close to a waxing crescent moon on the 14th. Uranus is visible in the evening between Aries and Taurus. As I said, close to the waxing gibbous moon on the 19th, and Neptune is in Pisces, visible after sunset, and on the 15th, close to the waxing crescent moon. Next one, please. So this is a nice wide field photo op. We have to get up early, or not so early, 7 a.m. on the 8th, and it'll be cloudy, usual. But if it weren't cloudy, Mercury, Venus, and the Moon in Scorpius. Next one, please. January 27th, early in the morning, but not too bad. 7:15. Venus is in Sagittarius, and you can see the conjunction between Mercury and Mars. Very close conjunction. So they're going to be low, so you'll need a good southeast horizon. But a nice wide field photo op, and probably a nice telescope shot. Mercury and Mars. A Matsakov or Shikasky. Okay, well, we've already had the quaternids, and fortunately, we didn't get to see much of them, although Jerry thinks he might have caught a couple. Explore the universe, winter constellations, Auriga, Gemini, Taurus, Orion, Canis Major, and Canis Minor. So these are constellations you need to observe and record for Explore the Universe. Pretty easy to see from scope, southeast. Next one, winter stars. Number 1, Sirius, the brightest star in our sky, and a few other bright stars: Capella, Rigel, Procyon, Betelgeuse. Lots of stars. Again, these are stars that are part of Explore the Universe program. Next one, please. And winter deep sky objects. So we have an asterism, Kemble's Cascade, which is just there, well above M37, and the challenge for winter deep sky objects is the Orion Nebula is not the challenge. The challenge is these 6 stars, the trapezium. So the 4 of them are easy to get, but number 5 and number 6 are pretty close to the major stars. So that's your challenge, to observe those. You'll need pretty good seeing. Please. Winter double star in Delta Cephei. These are prototypes. They're Cepheid variables, and pretty star. The yellow star and the smaller blue star. High up in the sky in Cepheus, so just at after sunset, so an easy winter double. Again, part of Explore the Universe. Some please. And if you haven't seen Algol, also known as Beta Persei or the Demon Star, tomorrow night, well, it's going to be cloudy.
You won't see it tomorrow.
You won't see it tomorrow night. If you've got the Observer's Handbook, though, there's I think one more decent opportunity this month to see at least the not the whole bright to dim to bright, but at least to see the dim to the bright. All right, I think that's it. So, any questions? there's no questions. Pardon? Copernicus. Yeah, I think I took this with 4-inch Mexico.
Have you ever checked that image to see if you've seen the weather domes and surrounding plains?
The scene wasn't that great. So I don't, I've got better images.
I think I've seen it.
Yeah.
Whereabouts?
5 o'clock, there's a crater left, about 1.5 diameter.
Yeah. Right there.
Lower right of that, it looks like there's a spot. So good. It's not a crater.
Yeah. Okay.
Could you just move to the other side and point to that again?
Oh.
Field.
Right there.
They would be, yeah. And the other place to look for those would be the visible events and winter program. He points out a lot of those.
Yeah.
That's the whole purpose of the program, is not just to observe craters and seas, but to learn the geology of the moon. Points out all those features.
Okay, I think that's. Oh,
Dave, a question?
yes.
You had mentioned there was another opportunity to see algal at minimum the rest of the month.
Yeah, I don't remember exactly when, but they're laid out in the observer's handbook.
Oh, she's showing off.
Oh, she's got it. Oh, perfect. We'll put her on the screen.
Let's see. I don't know if you can.
I don't think that's working for
That
everybody.
very well. Let me just tell you that according to this, algal is at a minimum on the 4th, 7th, the 9th, which is interesting. The 12th, the 15th, the 18th, basically every 3 days.
Now we know the bottom dates this month.
Yeah. Although whether some of those are
What
going to be
page is that on?
during the day, right?
Yes,
Sorry, Judy, what page is that on?
99.
99.
All you have to do is look at the bottom of your book, and there's a grayed area. That's all the calendars.
Yeah.
But January is on page 99.
So lots of opportunities this month and in following months to see algal. All right, I think that's it for today. Unless anyone has something you want to talk about, anyone get a very cool. So it must have been some good astronomy gifts over the holidays.
Explains the clock.
Explain the cloud and the upcoming snowstorms.
I've got Neil deGrasse Tyson's new book,
Well, there you go.
which is at the level that I can understand. So it's, I've got it about halfway through. It's pretty interesting.
Well, you should do a review on it for Nova Notes then. Yeah.
Apparently, nobody could hear you.
Oh, sorry. Neil deGrasse, his book To Infinity and Beyond just came out at Christmas time, and it's everything you want to know about space, but explained simply with interesting stories, and yeah, it's a good read.
I second what David said. We would love to have a review.
I think I've got a fellow reader back there.
No, this is a different book. Bob
Oh.
would like to talk about this book. Should be able to talk.
There, I think can I be heard?
Yeah.
Okay. Yeah, I was fortunate to be able to go to the other side of the world for about a month, and among other things, got some shots of a couple of constellations that we don't see very often here. But I also managed to pick up at a library in one of the small cities something called Southern Nights, and I can't show it on the camera, Jerry. I don't think it's going to show up.
Not really.
Okay. And I'm still reading it, so it's not ready to be handed around yet, but it's a good history from New Zealand's perspective of what, about basically the universe and all the things in it. It has cultural issues, deals with some excellent photography, not to mention the fact that the observatory is also mentioned. So worth to read, and quite happy to share it once I've finished it.
Good. I just got an email from Celestron saying there's going to be a big announcement on the 8th. And I think I know what it is, but I can't say. You only have to wait a couple days. Well, it might cost that much.
At least a piece of glass that was cut out of it.
Right.
So you'll be able to put this next to your S50, will you?
I had some inside information from a fellow Halifax member who said that I couldn't say anything.
Let's just say this: is the room left in your basement?
No, nor in my bank account. I think.
Excellent, Judy.
Yeah. Anything else? Okay. Well, thanks everyone. It's good.
Thank you.
We'll see you next month. And thank you to our technology wizards, Jerry Black and Bob Russell.
Yeah, next month our speaker is Chris Kerwin from Astronomy by the Bay. So we'll have
great.
an exciting talk from him.
That'll be fun.
Thank you.
David?
Yes.
It's not